So in the previous video, we actually talked about the bouncing issue. Alright, we actually talk about storing the array. Alright, we can restore the values and then we print the values. Alright, using the for loop, as we have said over here. Alright, we store everything and then we print all the analog readings. Alright, but why do we store and why do we print? Because we actually want to store the information. Because for our purpose, if you still remember, we are actually looking at the button bounce. We are actually looking at the button bounce scenario. Right? We're trying to see how fast it bounces and things like that, or how does it constitute to whatever thing that you want to look at. Alright. So in order to explain this, or in order to get in all the analog data regarding this button bounce, alright, we say that we connect the button, alright, one side to the analog, one side to the digital, alright, with a resistor, alright, that is about approximately 2000 ohm. Okay, after connecting in that manner, then we can actually read the analog signal for your button press. So once you press, alright, once you just press this button, just press only, alright, you can straight away plot many points regarding this bounce over here. Okay, so this is the purpose of this video, but I'm not going to do it, but I'll just show you this video and you can watch yourself. Alright, so I'll just start off with this video with a speed that is about 1.5. I think you'll be good. Alright, so let's start.
So this is the program I wrote earlier, right? So what I have done is okay, first I define my big pin, right, as my input pin. Okay, this one, I don't define this one, I define C. Okay, so this one initialize my serial monitor. Okay, and this one define my resolution for analog reading. So this one I define my this array, right, as a 1000 element array. Okay, so this one I did not define, but it's the same. Okay, then so I introduce some delay. Right? Okay, so now actually the problem is when do you need to capture the data? Actually, this is the problem. See? You cannot capture all the time, right? Because for Arduino, right, you have limited memories to capture the data. Right? So when do you need to capture the data? Right? So I put a condition here. So basically, when the analog read, right? So analog maximum value actually is the 4095. So when you did not press the button, right? So actually the analog reading will be always very high value. So I have already checked, right? So it's somewhere it's 4095, right? Somewhere it's value. So that means if I put a condition here saying when my analog read values, right, is bigger than 4000, right? That means I haven't pushed my button, right? I haven't pressed my button, right? So for this case, I don't keep the reading, but I wait here. So this actually is similar to what you have seen in the lab, right? What do we call this one? What do we call this one? Oh, we call it polling line. Right? Right? So basically, for this case, we are waiting for the push button to be pressed. Okay? So now if your analog read value, right, is less than 4000, right, that indicates you already press button, right? So now I want to start reading, right? So for this case, I save 1000 numbers, right? Use the for loop, right?
And over here, you may wonder why do we have a smaller than 4000? Okay, because for example, if you remember your 12 bit, alright, for example, where am I? Your 12 bit over here is 2 to the power of 12. Maybe I should use a different color. 2 to the power of 12, which is 4096, I think. Alright, so over here this is full bit, alright, when you didn't use any memory. Alright, but once you press the button, alright, once you press this particular button, you're gonna take in more memory. Alright, so therefore the space that the leftover bits that you can use, it will be lesser. Alright, so you'll be like maybe 4055. Alright, so I think you get what I mean. So therefore once you press the button, alright, then the number of bits available for you to use will be lesser. Alright, and therefore if your analog, while your So while your analog read, alright, while you read pin 8, alright, as more than 4000, okay, this means that you're actually over here. Alright, this means that when you haven't pressed anything yet. Alright, so once you press the button, alright, then your number of bits will actually decrease less than 4000. Alright, less than 4000. So this means that okay, your Arduino starts to take in memory already. Alright, so once it takes in memory, then you'll start this loop. Alright, this is the loop that we have been using just now, alright, to actually do the storing part. So this thing over here is the storing, or this thing over here is the reading. Alright, sorry, this thing over here is the storing, this thing over here is the printing. So you print out whatever thing that you want to print. So you print your analog readings, alright, in terms of a decimal, or in terms of base 10, if you still remember. So you print you print all whatever value that you want. Okay, so this is what they're trying to say. Okay, so take note of the polling word also. So when your pin reads certain values smaller or bigger or equals to some values, this is called polling. Alright, so you somewhat polled, alright, so to speak. So the word polling is actually to check the status of your device. Alright, so therefore what we do is to actually check the status of our device. Alright, so if the button is pressed, then you can do something. So this is the steps. Alright, so let's just continue and see what he can say.
So I save it, right? I want to clean up my data to the serial monitor. So after I bring out the data to the serial monitor, then I can copy the number to the Excel and do the plotting. I show you my plot. Okay, so this program actually is very simple, right?
Okay, just take note also is that all your stuff, alright, all your information, if you take a look, I just realized also, alright, is that if you give me a while, is that you write everything before the void loop. So you write everything inside the void setup, you see. Or I don't know where am I, but I don't know where the void setup is, but at least you get to see that we are writing before the void loop. Alright, so we are not putting in the for loop everything within the void loop. We actually put it in the setup, alright, for the analog reading. So this is something that you also want to be aware of. Alright.
So basically, I read the value first, then I bring out the data. Like in this way, actually, I can capture the very short transition for the switch box. Okay. Yeah. So I show you my outputs here. Okay. So this is the data actually I captured. Right? So you can see the transition, right? So actually, this value here, the y-axis actually is the analog. Okay, so this is
yeah. Okay. So before it goes dark, alright, this is the switch box that is being plotted out. Alright, once you get the numbers and then you copy inside the Excel, alright, so you'll get the stuff. Alright, so once you serial.print, alright, you generate a list of datas, then you're gonna plot it inside this Excel sheet, and you'll get something like this. So you get to see that over here, this takes about 15 milliseconds in order to actually reach stability. So normally you want to delay for 15 milliseconds, alright, before you initiate anything, alright, before you read the state of your button. Alright, so I repeat again, you want to delay for 15 milliseconds before you read your state of your button. Because if it will happen that you read the state of your button, if happen that you read the state of the button when it is kind of spike up, alright, then you may actually read it as this point. You see? Or you may actually read it at this point. So actually it's not very accurate because you want to read the button state at this point, but however, because of this spike, you actually read at this point. Alright, so this is something that you may want to be careful of. And nonetheless, I shouldn't say that it read at this point, but I should say that so sometimes it may actually spike up higher than your initial one, so you may actually read it as this point over here, which is very high. Alright, so this is logic 1, this is logic 0 lah. Okay, so if you were to spike it up, and then you'll keep on going to logic 1. Alright, so therefore normally we want to actually delay for about 15 milliseconds. Alright, when everything cools down, then you can just read your state of a button. Alright, so I think this is it for everything, and I hope that this gives you a nice summary of everything. So yeah.